Hey folks, Mr. Dell here. We are looking at a problem that has us explore Pythagorean triples. So I'm going to review Pythagorean theorem and talk about these patterns of Pythagorean triples. So I'm pulling this specific question from this is from CPM's Math 2, Integrated 2, and this is section. Actually, this is the closure. This is chapter 6. Oops, chapter. Try that again there. Chapter 6, closure. Okay. All right. So it says, use what you know about Pythagorean triples to determine the length of the third side. So remember, when you have a right triangle, any right triangle, right? And we know it's a right triangle because it tells me there in the corner of this angle, this little box tells me that's a 90-degree angle, a right triangle. We know that we have this Pythagorean theorem that says that a squared plus b squared equals c squared, right? Well, what is that? Well, in short, really that means that you just take one of the legs, and you square it, and then you add it to the other leg and you square that, right? The square of the legs, the sum of the square of the legs is always equal to the hypotenuse squared. The hypotenuse is the side opposite the 90, the longest side of your right triangle, right? So that's what this a squared plus b squared equals c squared is. So if I'm going to label those, I could say this is my a, this is my b, and this is my c. So let's just do the math on this one, and then I'm going to talk about this Pythagorean triple thing. So if I did the math, I would say this is 12 squared plus, I don't know what my b is, so we're going to call it x squared is equal to c squared, which is 15 squared. And so that's 144 plus x squared is equal to 225, right? And then if I'm going to figure out what x is, I would solve for x. What I want to get my x alone, isolate my x squared. So I'm going to actually, in this case, subtract 144 from both sides to make that is 0 to get my x squared alone, 144. And you end up with x squared is equal to, looks like 81 in this case. Okay, so that means I'm looking for the number that's squared to be 81. What times what is 81? Well, if you don't see it right away, the operation here is the square root undoes the x squared, right? So the answer, move that over here, would be x is equal to 9. So that means b, this side length here, is 9. Okay? So that is a nice number. And so why that being a nice number, these whole numbers are Pythagorean triples. Well, let me show the pattern of what and how we could come up with that triple if we knew the pattern of some of these. One of them is to know the most common Pythagorean triple is the 3, 4, 5. Meaning if I have a right triangle and one of the legs is 3, one of the legs is 4, guaranteed the hypotenuse is 5, right? Because a squared, 9 squared plus 16 squared, right? Excuse me, 4 squared is 16. So 9 plus 16 equals 25, right? A squared plus b squared equals c squared. So, and then if this is a Pythagorean triple, then you have any multiple of those three numbers is also a Pythagorean triple. So in other words, if I take this 3, 4, 5 and I double, right? Talk about doubling all the side lengths, now becomes a 6, 8, 10. That is also a Pythagorean triple. If I were to triple each of the sides, that would be a 9, 12, 15. That is also a Pythagorean triple, which is this triangle here, the first one here. So if I knew my 3, 4, 5 pattern, right? If I was familiar with that being one of those Pythagorean triples, 3, 4, 5, then any multiple, I can multiply any a factor, any scale factor, I should say, any scale factor of 3, 4, 5 is also Pythagorean triple. So being this is a scale factor of 3, because it's 3 times as much each side length, it is a Pythagorean triple. Okay. So what about B? Well, B, there's another common Pythagorean triple that we're going to explore, but let's first see what this is here. So that's X, right? So again, if I don't know my Pythagorean triples, I could do the math to figure this out, So if we were to do the math, we would be taking Pythagorean theorem, which is a squared. That's going to be my a. That's my b, because my c is always the hypotenuse. So I would do 10 squared plus 24 squared is equal to x squared, right? So in this case, that's using a squared plus b squared equals c squared. So that's 100 plus, let's see, so that's 5. Shoot, I don't have that one memorized. So 24 squared is 270 or 576 is equal to x squared. So this becomes 676 is equal to x squared. So once again, if I need to, I can use, in this case, I'm going to be using my calculator to determine what is the square root, right? Because we're trying to figure out what x is. To figure out what x is, I got to do the inverse, the opposite of square to square root. So I square root both sides. And so the square root of 676, because that's what this is, 676, the square root of 676 is equal to 26. Okay, so now that tells me that this side length is 26. So what we have, and I'm going to show you one of the other common Pythagorean triples is a 5, 12, 13, right? If I had a side length of 5 and 12, two legs, 5 and 12, then that is 13. The actual hypotenuse is 13. And if you think about 5, 12, and 13, if I double it, right? If I double that, if I have a scale factor of 2, 2 times 5 is 10, 2 times 12 is 24, 2 times 13 is 26. So that's why this 10, 24, 26 is also a Pythagorean triple. Okay, there we go.